Okay, for number 5 in section 5.3, we're given that f of x equals square root of x minus 4 and g of x equals x squared plus 4 if x is greater than or equal to 0. And it says to prove that these are inverses analytically and graphically. So first, to prove that they're inverses, we know that to be inverses, f of g of x has to equal x, and g of f of x has to equal x. And so, what we're going to do is plug g of x into f of x. So, f of g of x equals root. That's what f of g of x is, because we just plugged in x squared plus 4, which is g, into our f function. So that's going to end up being square root of x squared, which is just x. So far, 1 is right. Now, let's check g of f of x. So we're going to take our f of x function, which is x minus 4, and plug that into g of x. We're going to have that squared plus 4. And so, what we end up getting, right, yeah, square root of x minus 4 squared. Okay, so what we end up getting, x minus 4 plus 4, which just equals x. So both equal x. So they are inverses, and that's how we proved analytically. Now, graphically, if we look at these, the square root of x minus 4 is going to look, if we shifted 4 to the right, it'll look roughly like that, something like that. This is like 4. And if we take x squared plus 4, but only when x is greater than or equal to 0, then we're going to get, shifted that 4, we're going to get like that. And so, let's take a point. So let's say we plug 0, oh, we can't do that. Let's plug 8 in. So when x equals 8 into this function, we're going to get 8 minus 4 is 4, y is going to equal 2. Let's plug 2 now into this function. When x equals 2 into g of x, we get 2 squared is 4, plus 4 is 8. So see, they are inverses now graphically too, because we proved that the x's and y's are just switched.